All right, in this video, what I want to show is the relationship with the dot product. So normally this is the absolute value. For our notation, I'll usually use this as the norm, unless, or I'll sometimes write the norm down here in my notes and stuff like that. Uh, Sometimes you also will see this written as uh, the double to indicate it's different than the absolute value. But we are computing the norm. And so the norm is the square root of v1 with itself. Okay. So taking the dot product of v1 with itself means I have -5 times -5, which is 25 plus. I have 3 times 3, which is 9 plus. I have 2 times 2, which is 4 plus. And then I have -5 times -5 is 25. Okay. That's going to give me 50 plus 13. So let's see the square root of 63. Okay. Which I think that's 9 times 7, right? So we can simplify that as 9 times 7, which means we can write that as 3 square roots of 7. Okay. All right. The norm of v2 is the square root of 1 times 1 plus 3 times 3 plus 2 times 2 plus 0 times 0. Okay, we can give us the square root of 14, which is the square root of 14. Okay, so that's the norm of v2. All right, now for this one, we're going to compute the distance between them. So I first need to find the distance and then take the norm of that. Okay, so I guess it won't matter. I'm just going to think the best way to write this. So, um, so I'm going to come over here and go, nope. V1 minus V2 is equal to subtracting them component-wise, -5 minus 1, 3 minus 3, 2 minus 2, and -5 minus 0, which gives us, this is going to be what, -6, 0, 0, and -5. Okay, so that's V1 minus V2, and then from here, I want to compute the norm of this one, which means that I'm going to be taking this vector and dotting it with itself, or taking the inner product with itself. Okay, so it's going to give me -6 times 36, -6 times -6, and then plus 0 plus 0 plus 0 plus 0 plus 25, which that total gives me a sum of 61. Okay. All right. Um, and then it's trying to read my handwriting here. This is V1 dotted with V2. So in that situation, I'm testing to see if they're orthogonal. So if the inner product of these two turns out to be 0, then by definition, we consider those two vectors to be orthogonal to one another. Okay. So I'm going to have -5 times 1 plus 3 times 3 plus 2 times 2 plus -5 times 0. Okay, so this is going to give me -5 plus 9 plus 4 plus 0. Okay, so what we have here, this is going to be -1. These two is going to give me -1 plus 9. This is going to give me a total of 8, which is not equal to 0. So V1 is not orthogonal to V2. Okay, all right, that was it. I hope that was helpful. I'll see you in the next video.